Greetings, class. First, my apologies for getting a little bit of a late start on this week in terms of your materials for the week of September 12th. I will try this week, hopefully, to get a little bit ahead. I had mentioned earlier in the semester that I was going to try and post additional future weeks materials early for those of you that wish to work ahead. So my apologies for a late start on that. Also, I wanted to also mention that it was my hope not to appear off-putting with the emails that I sent out about not accepting assignments via email and all the things related to that. It's really easy for the email traffic to get out of control, and when people are sending multiple emails with multiple attachments to each one, it's very difficult to keep track of everything, and it's much easier if we have a centralized method of turning things in. That's what Blackboard is all about, and Rhiannon and I are working hard to make sure the Blackboard is working efficiently. I very much appreciate the things that many of you have brought to my attention when things are amiss or aren't working completely correctly, and it allows me, of course, to make sure that things are working correctly. This first segment, there's a couple segments this week. This first segment has to do with box plots. Box plots are really our first graphic that truly shows a lot of information in the form of a couple of measures of central tendency, as well as a couple of measures of dispersion. The other thing that I like about box plots, there's a couple things that I like about box plots. One is that box plots allow us to determine right away whether or not a distribution has skew or not, and also how much skew it might have. The other thing, or another thing I should say, that a box plot shows us, or can show us once we get used to interpreting them, is the shape. The relative shape of a distribution. Some of you may recall from prior YouTube clips that understanding the shape of a distribution is going to become an increasingly important concept as we move through this semester. So very quickly, I just have a couple things I want to show you related to box plots. This is, if you haven't downloaded this from Blackboard, you might want to do that. In fact, you go ahead and pause this video and do that. But basically, this is a drawing of a typical box plot, and I also took the opportunity to define the various parts of a box plot. So, for example, you can see that there are two measures of central tendency represented in a box plot, and those measures of central tendency are the mean, represented by the dot, and the median, represented by the middle vertical line. So there are two measures of central tendency in a box plot. They are the mean, the dot, and the median, the vertical line. There are also two measures of dispersion or variability represented in a box plot, one of which we've talked about, the other one which we have not talked about too much. But the two measures of variability are the range, which is simply the edges of the lines. Technically speaking, this is called a box and whisker plot, and those things that my two fingers are on right now are referred to as the whiskers. But those whiskers, or I should say the edges of those whiskers, are the range of the distribution. So as you can see, just the imaginary scaling that I've created here, the range of this distribution is 0 to 100, or 100 if we were reporting it as one number. So two measures of central tendency, the mean and the median, and two measures of dispersion. One is the range. The other measure of dispersion is what's referred to as, and hopefully you saw this mentioned in SPATs, is the interquartile range. The interquartile range falls here on each edge of the box. So the lower end of the interquartile range is represented by this vertical line, and the upper edge of the interquartile range is represented by this vertical line. And the interquartile range means that we have the middle 50% of the distribution. So for example, one thing that's not included on this drawing, but you can add it, this is the lowest 25th percent. This is the highest 25th percent. And the middle, the IRQ, is the middle 50%. 50%. I realize that my writing is kind of messy, but the bottom line is the interquartile range is identified or defined as the score that falls at the 25th percentile, the 25th percentile. So that means that from the edge of this box to the end is the lowest 25% of the distribution, and the 75th percentile. So from this edge of the interquartile range, or this edge of the box, to the end of the range is the top 25th percentile, leaving in the middle 50%. I have a couple of other items or examples of box plots with less writing on them. This is a box plot. As you can see, there's no numbers, there's no scaling because this is just a hypothetical situation. But what I can tell from this box plot, again, I can see that there's a mean and there's a median right here. The mean is the dot, the median is the vertical line. And further, I can see that the mean is being pulled away from the median. If the mean and the median were exactly together, like if that dot was right on that line, then this distribution could be said to have no skew. There's no skew at all because the mean and the median are right together, right in the middle. Not the case with this. With this case, with this example, the mean is being pulled lower, pulled away from the median, indicating that this distribution has negative skew. And you can kind of see that because we have more of a distribution of the scores, or a larger portion of the distribution here, which makes sense that we would have negative skew because we've got these few outliers down here, outliers, pulling that mean away. Also, the two measures of dispersion, the range and the interquartile range. And I'm going to write something hopefully a little bit more clear. This is the 25th percentile score, and this is the 75th percentile score. 25th percentile score, 75th percentile score. So the interquartile range, again, contains the middle 50% of the distribution. Another example of a box plot is right here, a little bit different here. Now we can see that we have a mean and a median, but in this case, the mean is being pulled higher than the median. So we would say that this distribution probably has positive skew, pulling that mean away from the median. Also, we have the total range, low and high, and then we have the interquartile range, which again represents the 25th percentile score. So this score right here would have 25% of the distribution below it, and the 75th percentile score, this score would have 25% of the distribution above it. And then in here in the middle, this middle interquartile range box is the middle 50% of the distribution. We're not going to do a whole lot of work with box plots, but I do want you to be aware of at least what's contained in them. Depending on how the rest of the semester goes, we may use that particular graphic to do some statistical testing. But right now, I just want you to know some of the utility of a box plot, something I mentioned at the top of this video, and also specifically the information that's contained in the box plot. Two measures of central tendency, mean and median, and two measures of dispersion or variability, the overall range and the interquartile range. Shoot.